Let A of r be the area of a circle of radius r. So we know that A of r, A, the area as a function of the radius, is pi r squared. We need to show that A prime of r is equal to the circumference of the circle, which we know is 2 pi r. So let's go ahead and do that. Well, A prime of r is going to be equal to, now we're going to take, our variable is r, so I'm going to write it like this. First of all, it's going to be something plus a small change in the variable. Okay, so it's going to be the area. You know what, this is all correct, but I'm not explaining this very well. Okay, so let's just, let's try this again. So it's going to be A prime as a function of something is equal to that function, the original function, evaluated at something plus a small change in the variable, minus the function evaluated at that something over that small change in the variable. And specifically, I know I'm leaving this out, but specifically we want, for this guy right here, we want the change in r, the change in the variable, to become really small. Okay, so what is this over here? Well, if we want to find A prime of r, that means that we got to stick an r in here, which means we got to put an r right here, which means we got to put an r right here. And so what is A of r plus delta r? Well, that's this guy right here, so it's pi times r plus delta r squared. So this right here is this right here, and I'm getting it from this function up here. So minus A of r, which is pi r squared. So this is equal to this, again because of this. And we're going to divide by delta r. Again, we're looking at delta r gets really close to 0. So what is this? This is pi times r squared plus 2r delta r plus delta r squared. That's what this guy right here is foiled out. Then minus pi r squared over delta r. Now we're really doing some math here, right? Okay. So we're not just plugging around numbers, we're showing that the area of a circle is related to its circumference. That's a crazy idea, right? The area of a circle, if you take a circle and you find the area inside of it, that is related to the distance around the outside. Okay? Maybe that doesn't surprise you, but I mean, man, it's a cool thing. I mean, that's really what we look for in math. We look for these relationships. So if we finish up the algebra here, we've got pi r squared plus 2 pi r delta r plus pi delta r squared minus pi r squared over delta r. And that's going to be pi r squared. Oops, I'm going to cancel some stuff out before I do this. So here the pi r squared and the negative pi r squared, those guys cancel. And so I'm left with 2 pi r delta r plus pi delta r squared over delta r. And so if we factor out a delta r, on the top we have just 2 pi r plus pi delta r over delta r. These guys can cancel, and we're left with 2 pi r plus pi delta r. Now, as delta r becomes really small, this guy goes away. Because pi times something super small becomes super small, and that guy goes away. And so look at this, is equal to 2 pi r. So a prime of r is 2 pi r. And that is what we were looking for. If you don't feel somewhat satisfied after that, man, go back and look at it again, because that's pretty slick.